Mark Trotter at University of New England. I'm a senior lecturer in precision agriculture.
So we're talking about technology and the development of technology, particularly in mixed farming. What did you look at today as the potential opportunities and what's potentially out there already when it comes to technology which may be able to assist mixed farmers?
Yeah, so I guess if you look at the challenges that mixed farming producers are facing, there's a number of critical issues. So you look at variation in soil nutrients, both in that cropping and that pasture system. And then it's about, I guess, one of the other issues is matching the available feed that you have with your animal demands and how you do that. And then also just monitoring those animals in a mixed farming system when you've got so many other things going on at the same time, knowing what those animals are actually doing, are they healthy, issues like that. And labour use, just overall labour use efficiency.
So from a technology point of view, you mentioned there monitoring. What sort of opportunities and technology is out there that can potentially help these producers monitor their animals?
Yeah, monitoring animals in particular. So there's some really interesting emerging technologies. So things like tracking devices that we can put on animals, just like almost like a mobile phone on an animal, if that makes sense. And we can actually monitor where they are, which part of the paddock that they're in, and then also monitor their movement and their behaviour and see how that's changing. And there's a lot of different uses for that sort of technology.
So you say a lot of different uses. How can you use that type of information to improve the outcomes of the operation of the property?
Yeah, okay, so there's a number of different ways, but some of the things we're looking at are, for example, understanding how animals move nutrients around a paddock, so we can get to a point where we're actually making decisions about variable rate fertiliser based on nutrient redistribution by livestock. Understanding where they're up to in terms of the feed that's available to them. Their behaviour changes significantly when they start running out of feed, so we can actually provide a bit of an alarm that they might be turning off feed and it's time to go out and check them. All the way through to things like disease detection, understanding that animals are starting to show symptoms of a particular disease, whether it's nematodes through to metabolic diseases caused by brassicas or whatever it happens to be. Yeah.
What about the bottom line? Do you believe that these advances, this technology, can actually improve the financial performance of agricultural businesses?
Yeah, definitely. Look, if it doesn't turn a dollar, it's not worth putting the effort into, for sure. And there's been a number of economic studies done by various groups, most recently by MLA, looking at the potential value and returns to farmers of these particular technologies. And it ranges, obviously, according to the particular farming system, but some of the dollar values around, say, on-animal monitoring systems, having an e-tag that could do some of those things I was talking about, range between sort of $50 up to $125 per hectare, total farm productivity growth of 8 to 12%. So there really is some good potential dollar values in terms of getting this technology working.
Overall, we've talked a lot about the animal side, but what about plant side? Is the technology there to improve the performance? And for a number of years we've looked at weed-seeking devices, etc. They really haven't seemed to have advanced or been implemented on many properties. So is it just too hard and too expensive and the returns aren't there, or what's the issue from a plant point of view with technological advances?
Yeah, so if you look at, say, something like managing weeds selectively in a crop or a pasture sward, one of the key challenges we've had is a green weed in a green crop. And the technologies like Weed Seeker, which work quite well, are essentially limited to fallows where you've got a green weed in a fallow situation. We're now getting technologies which are actually working more on image analysis, so actually identifying the green weed and the pattern of its leaf, whether it's that star shape or whatever it happens to be, inside a green sward, which means we can identify that weed and then we can target that weed in crop, which can be potentially will be a big win. Still a long way to go in that particular space. There are commercial technologies out there, but still a little bit rough around the edges, I think, in terms of operating. But in time, we will most certainly get to the point where we're able to do that sort of stuff.
Dr. Mark Trotter from the University of New England, thanks for talking to us today.
No worries, thank you.